In this video, we're going to look at stationary points. And stationary points are points on a function where the gradient of the tangent to the curve is 0. So you have a horizontal tangent if the gradient of that tangent is 0, and you have that your derivative is equal to 0. So for this particular function here, we have 2 points where it has a horizontal tangent, one here at x is equal to a and one here at x is equal to b. And what we've got at this point here is that for the equation of the tangent, the derivative evaluated at that tangent, because the gradient is the derivative, is 0. And the same here. So you can see that this value here, this point here, has a higher f of a value than this point here. And it is the highest f of a, or the largest f of a value in this whole area here. So this point here is the maximum. In this little region of the graph over here, this point here has the lowest f of x value. And so this is a minimum point. So the maximum stationary point, a turning point, a maximum value, has the highest f of x value, and the minimum has the lowest f of x value. So one of the things we're often asked to do is to find the coordinates for the stationary points. And to do that, what we need to do is solve the derivative equation equal to 0, and that will give us the x value. So that tells us the x value at which the stationary point occurs. To find the actual coordinates of the point, we then have to substitute that a value that we've just found into the actual formula for the function itself to find f of a, and that will give us our y coordinate. So let's have a look at this example. Find the stationary points for y is equal to sine of 2x for x is an element of the set of numbers between negative pi and pi. So to find stationary points, the first thing we need to do is to find the derivative. So the derivative of sine 2x is 2 cos of 2x. So we find that derivative. Then we let the derivative be equal to 0, and now we need to go back to our work from chapter 6 and solve this trig function for x, which means rearranging so that it becomes equal to 0, and then readjusting our domain here so that it reflects what's actually in these brackets here. So we've got 2x here, so we need to have 2x is an element of. And to get from x to 2x, you multiply by 2, so both of the end points of the domain are multiplied by 2 as well. So now we've got to solve cos of 2x is equal to 0. There's a couple of ways that you can do that, one of which is using your unit circle. And on the unit circle, our cos axis is our x-axis, and we want cos of 2x to be equal to 0. And so that means that our points needs to sit above the origin. So we're after this angle here, which is pi on 2 from 0, and this angle here, which is minus pi on 2. So we've got these two here. So our domain goes from minus 2 pi. So if this is 0 and we come back, that's minus 2 pi, and that's minus 2 pi, minus pi on 2, and this one's minus 3 pi on 2. And going in the other direction, from 0 to 2 pi, we pass pi on 2 and 3 pi on 2. And so we have that 2x is equal to those, but we're not after 2x, we are after x. So we multiply everything by a half. That gets rid of our 2x here, times this by a half, and then times each one of these by a half. And now we've got our x values. And so these are the x values at which the stationary points occur. But the question doesn't ask you to find the x coordinate, it asks for the stationary points. And so we need to find the y coordinates for these. So there's a couple of ways that you can do it. You can either substitute each of those x values back into the original formula. So you can take each one of these at a time and substitute it in here and work out what it is. Or you can use what you know about this particular graph, which is a sine curve, to figure out whether it's a maximum or a minimum. So if we draw the sine curve, and it's not translated, and it's not translated at all. So it has this particular format here and back in this direction, which means that the very first value above 0 is going to be a maximum, and it's going to have a y value of 1. And so this in our list here is pi on 4. So pi on 4, the coordinates of this particular point here are pi on 4 and 1. So this one here must be 3 pi on 4 and minus 1. And you can use that idea to find all of the points. If you are asked to do this on your CAS, which is what I've done here, it's out the way, let's just move that up a little bit, then you can see I haven't found the derivative and then let it equal to 0. I've done the whole thing all at once. And to get it to give me just the values that I need, I've restricted the domain for the function, and you'll notice that it's outside the solve function. So make sure that you're getting your domain restriction for your derivative of your trig function outside of your solve function. So basically, if I was doing this on CAS, I've kind of stopped at this idea here. At the top, I've got the derivative equal to 0, the derivative equal to 0, and find the x values for that. So this next one is a little bit of a weird example because the equation is weird. So find the coordinates for the stationary points of the curve y is equal to x minus 1 all raised to the power of n, where n is an element of the positive integers but not 1. Okay, so to find the coordinates of the stationary point, the first thing we need to do is to find the derivative and let it equal to 0. And so I've done that in one step here. So it's clear, if this was an exam question, the person marking your exam can clearly see that you have made a derivative. This is the derivative and it's equal to 0. So to find the derivative of this, we're differentiating with respect to x. And so we've got a chain rule happening here. So we've got the derivative of the outer times by the derivative of the inner, and you can see that I've kept the inner the same there. And so now what we've got is we actually have two things multiplying together, so I multiply them together to give 3nx multiplied by that brackets. Now we have two things multiplying together to give us 0, so we're going to use the null factor law, which means either 3nx is equal to 0 or that bracket is equal to 0. And now we're going to solve each of these for x. Now, in both situations here, we've got something that we need to think about. We've been told that the value of n is a positive integer. So what we've got here again is three things multiplying to give us 0. So 3 is not 0. The n, we're told, is a positive integer, so it's not 0, which means that that x value there must be 0. For this one here, we've got something raised to a power equal to 0. So the only thing that you can raise to any power to get 0 is 0. And so that means that that inside of the bracket must be equal to 0 itself as well. And so we get, for the first one, x is equal to 0, and for the second one, x cubed minus 3, x cubed minus 3, x cubed minus 1 is equal to 0. So again, solve for x, find your y by substituting in, and you will end up with 2 points. The first of which is 0 and then minus 1 to the power of n. And when you substitute in x is equal to 1 into the equation, you get your second point, which is 1, 0. And you can see that I've put a box around them to let the person marking my work know that they are my two answers. This next example is a bit of a classic question. The curve with equation y equals, and we have two parameters in here. We've got an a and a b. And it tells us has a stationary point at 1, -4. And then it wants us to find the values of a and b. And so if they want us to find the value of two pronumerals, they need to provide us with at least two pieces of information, one for each of the variables, or the parameters, so that we can find it. And we get that from the fact that they say that the stationary point is at 1, -4. The stationary point being at 1, -4 gives us two pieces of information. First, that the point 1, 4 is in fact on the function. And so we can substitute x as 1 and y as -4 into the original equation, and we'll come up with one equation. The second piece of information that the stationary point being at 1, -4 gives us is that when x is equal to 1, the derivative is equal to 0. And so we find the derivative formula and we let it equal to 0. And we know that it is equal to 0 when x is equal to 1. And so we substitute in and simplify. And now you can see that we're going to need to do some simultaneous equations. Now, instead of working out simultaneous equations by hand, I've done the simultaneous equations on a CAS calculator because I wanted to show you how you can set this up so that it works on a CAS calculator. And so you can see I've defined my function here. And then I'm asking it to solve. And what I'm doing here, you can see that I have made at the top here, -4 is equal to y with 1 substituted in. And that's what that is saying there, in exactly the same order. And then the second thing that I've got there is I've got dy dx, 0, this bit here says 0 is equal to dy dx, or d dx of y with x equal to 1, which is what this is saying here. And when I ask it to solve that for a and b, it pops out with a is equal to 4 and b is equal to -8. So you can actually engage your CAS calculator at this level here. It's important that you get, even in the exam, if it's exam 2 with your CAS calculator, something like what I've written here in green and something like I've got written here in blue, and then the two answers, that will be fine. So this question here, the curve with equation passes through a point and has a stationary point at 2,15, and this time they want us to find three variables or pronumerals, A, B and C, which means that hidden in this question here must be three pieces of information that I can make an equation with. For each one of the pronumerals you need to find, you need an equation. So our first equation is going to come from the fact that the equation passes through the point 0 and 7. That gives us this equation. The second information again comes from the fact that it has a stationary point at 2 and 15. And remember, stationary points give us two pieces of information. The first one is that we can substitute in that point to the equation and get another equation, so with 2 instead of the 0. And secondly, that our dy dx formula is equal to 0 and x is equal to 2. That's going to combine to give me the third equation there, and then I can solve using either algebra or my CAS calculator. If I was to put these into my CAS calculator, this is what I would write. So for each of the equations, I put the definition of y. So 7 is equal to y. I've already defined y. I'd have the equation there. Evaluated at x is equal to 0. 15 is equal to y. Evaluated at x is equal to 2. So this means this. And this means this. And then finally, 0 is equal to the derivative of y evaluated at 2, which means this. And when I'm setting my simultaneous equations up, I need to remember that I'm not solving for x and y, but the two values that I'm after are in fact a and b. And finally, some of the other sorts of information that they give you that allow you to find equations for solving for a, b, c and d. They might say something like the tangent at x is equal to 3 is parallel to the line y equals 4x plus 5. That means that the derivative, so the tangent's parallel to this line, which means that the tangent has a gradient of 4. And the gradient of 4 is the derivative evaluated at that particular point. X is equal to 3. So that 3 goes in there. The other thing they might say, something like the graph of the function touches the line y equals 3x plus 5. If the graph of the function touches the line, that's the key word there, touches the line, and doesn't cut it, then that means it's a tangent. And it's the tangent at x is equal to 0. That's where it touches. And so from that, we can deduct that the derivative evaluated at 0 is equal to 3.